Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss with you this meeting room third problem of Leetcode. Okay guys, so let's move on to the problem. This is a very good problem. Contain use of priority queue in a very good manner. Okay, so first of all we will read the description. So we are given n numbers, means we have 0 to n minus room, means we have total n rooms from number 0 to n minus n minus 1. Okay, now we are given 2d integer array meetings, where meetings I is equal to start I and end I. Means in a array we are given that a particular index I, a meeting is start I and end at end I. Like here there is 2, means we have total room 2 from number 0 and 1. Okay, then we have these some meetings. So first meeting start at 0 and at 10, second meeting start at 1 and at 5, third meeting start at 2 and at 7. Means and at 7 means, like if this is start at 7 and at 7. Okay, I will explain, this is written in the code as well. Okay, now what we have to do now, this is a half close time interval. Okay, now what is half close mean? If I'm meeting I am saying that it is start at 2 and at 7, that it means it start at 2 and end at 6, means 7 minus 1, and at 7 it again became free. So the total time consumed by a meeting is 7 minus 2, that is 5. Okay, total time consumed by 7 minus 5, because 7 is not include. So how 5? 2, 3, 4, 5 and 6, means it will consume time 2, time 3, time 4, time 5, time 6, and at time 7 it will become free. The total number is total time consumed is time 5. Like someone getting room for 3, empty at 3, take room at meeting start at 2 and at 3, then it means it will consume just 3 minus 2, that is one time, and at 3 our room will become free again. Okay guys, so now, and meeting are allocated to rooms in a manner, this is the condition given to us according to which we have to allocate the room number to a particular meeting I. Now each meeting I can be placed in an unused room with the lowest number. Suppose at a current moment I, we need to fix this ith meeting. Okay, we need to give a room to this ith meeting, and we have some number like number 0, number 1, number uh, 4. Suppose these three are the rooms free at the current moment. Okay, suppose it is 6, suppose it is 6, not it is 5. Suppose it is 6. Okay, then for ith meeting, if these three are free, then I will prioritize one. Why? Because one has the minimum room number. Okay, because one has the minimum room number, and my priority is to give the meeting as lowest room number as possible. Okay, and if there are no available rooms, means at current moment suppose we don't have any rooms. Okay, we don't have any rooms, suppose, then what we can do, we can put this particular meeting in a queue or in some other data structure, and when a room became free, when I like how it is, if I'm meeting I will come, room is not free. Okay, a single room is not free, then j will come, then meeting k will come, and then our 5 room will become free, then again some meeting come. Then for these three meeting, if suppose the number are 1, 2, 0, 7 and 6, if suppose these 5 room number are free, then for I we will allocate 0, because I is the first in the queue who is being waiting for very long time. Okay, j and j and k also come in the queue, it doesn't matter. Our first priority is to give a room to meeting I, because it is waiting in the queue. Now 0 will come, now next minimum is 1, so next minimum 1 will go to j, because j is waiting before k. Now for k we will give 2. Now these two number remains free, and for next meeting that will come, take room from these two meeting. Okay, I hope you understand. Means if a particular room is waiting, then we will give the room to the first one who is waiting from before. Okay guys, now, and when a room became unused, meeting should be given the room. start time. Okay, this is just a useless statement, I think. Like if for ij, suppose its starting time 1, its is 2, its is 3, suppose for a minute. Like, and at time zero room number free at time 5, then I want a room at time 1, but I got a free room at time 5. So it is common sense. I will give the meeting at time 5. Okay, I will provide room 0 to I at time 5. I cannot provide it before 5 because I got his free room at time is equal to 5. Okay, this is just this statement. I don't know why it is written. Okay, the main just a minute, should be given to the room. Okay, so the main choose of this statement, I think, like this meeting start at 1 and at 7. Okay, suppose for a minute, and we are providing it a room at 5. Now it cannot be free at 7. It cannot be free at 7 because it will free at 7 when we will provide it a room at 1. Now how, when will it free? So we will consume we will calculate the time taken by the meet. Now what is the time taken by the meet? 7 minus 1, that is 6. So it will free from 5 plus 6. 5 plus 6 means it will start at 5 and it will consume 6 unit of time, so it will free at 11. Okay, now instead of 7, our room will free at 11. This is the I mean use of this particular statement. Okay, this is just a common sense as well, but I don't know, I need to. Okay, so we have to return the number of the room that held the most meeting. Okay, because every meeting has some different, I mean, okay, and the number, the time period for which a meeting we held. Suppose in a room number, zero, we give a meeting that will come to end. That will last to the end. Okay, and before it, one serve 5 different meeting. Two room number two serve 6 different meeting. Okay, so we like this. We have to calculate which room number will serve the most people with meetings. Okay, and if there are multiple rooms, like zero is also zero is also held 5 number of meeting, 2 is also held 5 number of meeting, then we have to return 0 because 0 has the lowest number. Okay, half close interval we have already discussed, it is not including 1. Now for this example, okay, so we will take this example. Okay guys, so now we have a room. So how we will approach it? Just look at the approach. The code is very simple. In, like in hard, for hard problem, code are simple, logic is hard. Okay, code is very simple. If you know competitive programming, if you know TSA, if you have solved some problems, then you know what is the syntax, how we will write queue, how we will implement priority queue, how we will implement vector, and all these things. But the main part is the logic. So we will give our complete time to how we will think to solve this particular problem. There can be many ways, and if you go to discuss section, then you will find even 95 or 99% of the people are talking about two priority queue solution, but I am giving you only one single priority queue solution. Okay guys, so time consuming is already low because I am just using a single queue. Now guys, okay, so this is my queue. Initially I have two meetings, so what my queue will store, my queue is my priority queue. Okay, you can say it pq. Now what is my pq will store? My pq will store the time when a room number I will free. So initially at time 0, 0 is free. At time 0, 1 is also free, and I have only two rooms. Okay, just a minute. Just a minute, guys. Yeah, okay, now above space also we got now. So, okay, guys. So at time 0 comma 0, at time 0 we have 0 free, we have one room free. Okay, and we have total number of rooms is equal to 2. Now first meeting will come first, and there is a use vector. There is a use. Okay, use vector. This will contain the use of 0 and 1. initially meet is equal to 0. Meet means simply the meet held by a current meeting, it is 0, and initially the answer will be 0. Why 0? Because if we have only one room, okay, because the minimum number of room we have is 1 and minimum number of meeting we have is 1. So if there is single meeting, this meeting held by room number 0. So we will take meet is equal to 0, answer is equal to 0. It means we don't take any meeting yes, and answer is equal to 0. Okay, answer will replace. So you can take it -1 or anything else, doesn't matter. Now our meet 0 comma 10 is come. Now 0 comma 10. Now we will see what is our top priority queue, top element. Top element will always contain the first room number available to me at that particular moment. Okay, for this meet I, priority queue top will always contain the element whose second index is the minimum room number possible to me at particular moment for his particular meet. Okay, you will understand when I write the approach. Okay, so what you will say? Okay, I just erase this customer because I need to again erase, and initially this will 0 comma 0. It is 0 comma 0. Okay, so now for 0 comma 10 we will take it. So our time when this priority queue will come is 0. Now for how much time it is going on? 10 minus 0, that is 10. So next time when this room number 0 will free is 10. So what we will push back 10 comma 0 in our queue. Now 10 comma 0 means at time 10 our 0 room number will be free. At time 10 our 0 room number will be free. Okay, now guys, I have completely taken this, and meeting of 0 will increase by 1. So now meeting count increase by 1 and index is 0. Okay, now 1 comma 5 is come. Now for 1 comma 5 what is the top element? 0 and 1. 0 and 1, what it means? G1 and 5 meeting will be served by 0 comma 1. Now means at time 0 one room is free at time is equal to 0. Now when it will be free, it will come at 0, time taken by it 5 minus 1, that is 4. So 0 plus 4 is equal to 4. So this room will be free at 4 comma 1. 4 comma 1. Okay guys, but we know this is a priority queue, so topmost element will always be minimum one. We are uh, we are using a minimum priority queue. You can look here as well. I am using a min heap. Okay, I am using a min heap. So 4 1 come in front means 4 is minimum at 10. So means at time 4 I got a room free. So if a meeting is come between 4 and 10, I don't need to wait for 10. I will provide it room number 4. Its room number is maximum, but doesn't matter. Oh sorry, at time 4 room number is 1. At because our meeting should not wait so much. Means if I have something, if I have a room to sorry, there is one blunder, there is one mistake I did. Just a minute, just a minute guys, just a minute. One mistake, sorry. Now at time 0 our room is free, plus our time will consume is 4. Now according to it our room should be free at 4, but is it possible? Suppose if it is possible, no, because our room is free at 0, but we don't require a free room at time is equal to 0. We need only it as 1. So it is free at 0, but we will take it when we are at 1. So it is maximum of 0 and 1, because it is free before 1, but we can only use it when we are at 1, because at 1 we are handling a meeting. Okay, so it will become 1. So 1 plus 5 4 is equal to 5, so it will come to 5 comma 1. So 1 will also take one meeting, meet count same, but answer should be lowest. So it is 5 comma 1. 5 comma 1 come in, 5 comma 1 come in front. Now for next meet 2 comma 7, what is the element free to me? Now first element free to me is 5 comma 1, and we can see 5 is greater than 2, but the first room available to me for this particular meet is room number 1 at time 5. This is room number, this is time. Okay, time comma room number pair it is. So okay, so current time it is free as maximum of 5 and 2. Okay, it is 5. I will tell you, we will reduce its this maximum fault. Okay, We will reduce like this is maximum or not, something, everything like that. Now it is 5 plus 5 plus time consumed by 7 minus 2, so that is 5, so it will free at 10. Okay guys, so we can say it should be free at 7 but it will be free at 10 because we got room late, so we will free it late. 7 minus 5 plus 5 is 10, so our next room will be free at 10 comma 1. Now 10 comma 1 comes after it because 0 is minimum, so in min if 0 will come before, 0 will come before. So our room number 1 serve one more meeting, it will become 2, mate will become 2, and because 1 serve more meeting, so now answer will be our 1. Now for 3 comma 4, for 3 comma 4, what is top element? 10 comma 0, we will take it from the queue. Current element it come to, this is 10, I just erase it. Time it come is maximum 10 comma 3 10. Time consumed 4 minus 3 1, 11 means it will free at 11 comma 0. So at 11 our room number 0 will be free. It means room number 0 handle one more meeting, meeting is equal to answer will be the lowest of 1 and 0, means for 1 we also held two number of meeting, but because 0 has lowest room number, so we will return 0. Okay guys, now this is answer is equal to 0. We all can see at time 0 both room at free. So first meeting start in room number 0, then in room 1, then again then at time 5 we can see there is a meeting in room number 1. Third meeting start in room number 1 at 5 comma 10 period, means at time 5, and it will last till 10. Okay, at time 10 both room free, then in room 0 we will again held a meet. So similar condition we are using in our priority queue. Okay, starting and ending are same. Okay, concept approach is approach are different, but the starting ending time of particular meeting, the room given to a particular meeting is same. Now guys, what now I need to check 10 comma 2 maximum of 10 comma 2, like when it come, I will give you a very good example of it, so that it will give you wrong answer if you check like this. This is very important to tell you, this is very important to tell you. Okay guys, suppose this is just a common example. Suppose in our priority queue at current moment at time 11 our room number 1 is free, uh, at time 15 our room number 0 is free. Okay, so suppose our we have total room 3, total room, this is just another case. Okay, so total room are 3, number of rooms are free, n is equal to 3, meeting are, suppose at time 0 a meeting will come that will last to 15, at time 1 a meeting will come that will last to me at 11, then a meeting to me come at 20 that will last to 25. Suppose these three meeting I have, so this is my queue, this is my queue. First meeting initially everything is 0 comma 0 in my queue. Okay, I will explain you, everything is 0 comma 0, and second room is 0 comma 1. So this is my priority queue initially. So I will take 0 comma 15 and provide it to room number 0. So at 15 my room number 0 will be free. Now at 1 comma 11 means our meeting come at 1. So first room free is 0 comma 1. So we will give it room and it will free at 11. So at 11 our room number 1 is free. At 15 our room number 0 is free. Now for providing our priority queue is like this. Now for providing meeting a room to this meeting 20 comma 25, this room number will come 11 comma 1, but it is correct? No. Why? Because at time is equal to 20 our 15 comma 0 is also free, we can see. Okay, it free after 11 but it free before 15 before 20. So we want a minimum room number free at moment is equal to 20. We don't know when our room number is come. Okay, like suppose at this time this is 20, we want minimum room number, and at this time suppose is the timeline, here room number 7 will come, means I am free. Now here room number 5 will come, I am free. Here room number 2 will say I am free at this moment, this moment, this moment, but we don't have any meet. So if I have any meet till here, I will give it room number 7. After this and till this, we have already have room number 5. So we will give room number 5 because 5 is minimum. Now after 2, now we say we also have 2. So before 2 to 20, we will give room number 2. Now suppose if 0 will come and say, I am also free. So for 20, we will not see 7, 5, 2 and 0. Okay, they are also free, but the minimum room number for this 20 available is 0. So we will provide it to 0. Okay guys, so what we will do, we will see what is the best possible room number provided to me. So I run a while loop till my room number is less, my time when I do ith room number, when this you will say ith, when ith room number is free is less than 20, means we have a current room free before 20. What I will say, make it 20, means it will, because if I am saying it is free at time 7 and no meeting come till 20, so what I can say, suppose this is time 11, this is time 14, this is time 17, this is time 19, suppose this is time 19, then 11 will say okay, 7 will say I will, this is time, this is room number, 7 will say okay, I am free at 11, so I will also free at 20. Okay, so 7 will say, so what we will say, 11 comma 7, that is in our queue, we will make it 20 comma 7, means at 20 also we will have 7. Now 14 comma 5, it is 14 comma 5, but 14 is less than 11, so it is after q, it is after 14, 11 comma 7 in our queue. Initially what I want to say, our queue is should be look like 11 comma 7, then second index should be 14 comma 5, means at time 14 our room is free, at time 17 our room 2 is free, at time 19 0 is free. But if I am saying if they all are free at this particular time, then it they also be free at 20 because no meet is come. So what I can say, they will free at 20 as well. Mathematics, it is correct, 20. So in, because it is priority, so they will become sorted. So with 20 comma 7 will come at last because 7 is the biggest one. I just take some 7 come here, 0 come here. That means the minimum room number, second minimum room number, third minimum room number, the largest number. So 0 2 5 7. So for 20, when we are look, we will say okay, room number 0 is free at time 20, so we can take 0. Okay, so similarly here what we will do, we will make it 20, we will make it 20. So in 20 comma 1 and 20 comma 0, 20 comma 0 will come and first, 20 comma 1 will come as first. So we will provide this top room number. Okay, we don't want to traverse our priority queue again and again because it is log n operation. So this is not very costly. We can once update my priority queue and use for current ith. Okay, we will not need to traverse ith element, okay, and do so operation. Okay, so this is what I will do. So now just look at code. So I don't know whether I need it or not, but because it's not mentioned in our queue that the next meeting starting time is always greater, so I will sort it. It means if ith meeting start time is s, then I plus 1 meeting time is always greater than s. Okay, means the starting time of next meeting should always be greater. Now I will take in heap current free room. Okay, current free room, then the free room provided to me at current moment, then I am taken this use, this meet and answer. I already explained you, meet is count of meeting, answer is my answer, use n comma 0 till 0 comma n minus n. So initially at time 0, my 0 comma I is free, 0 to n minus 1 this loop will work, means at time 0 all the room from 0 to n minus 1 is free. Now from 0 to less than m dot size. Okay, this is m log n operation, sorry, n log n operation, basically you can say, where n is the size of the, this is, you can say capital log n. Okay, because small n is this, so it is capital N where n is the length of m. So n log n something, it is more than log n, but simply n log n. Okay, nearly about it. Then while the free time of current room is less than time I required, what I will say, I will take down this, remove this element, remove it, because I cannot update an element in my priority queue. This is the biggest fault priority queue have. I cannot update it. I can only do push and pop operation as much as I know. So I will push mi0, means the new updated time, this will be free at mi0. Initially they all will free at 11 14 17 19, but now they all will free at 20 20. Okay, this is, and room number remains same, room number remains same. So after this is uh, this is 11 7 14 5 17 2 and 19 0 will become 20 0 22 25 27. So room number provided to me will remain in sorted order. Okay, so now current time. Now what is the current time? Means the room provided to me at current time will be on the top. Room number is second element and on the top, and I will remove this particular room. Means I have used it. Now I am use the current room number, so I will increase it. And if my room number of use room number is greater than my mate count, then answer will be my room number. Means this is the room number, that will be my answer, and meet is this number. Means the number of times a meeting is held maximum in a room is meet. And if they both are equal, they both are equal, means one also having two meeting, but after some calculation zero also have two meeting, so answer will be minimum of answer and room number. I am taken in because I take tong long everywhere. Okay, so this is room number. Okay, minimum room number will be in our answer. Now time taken by current meet is ending time mi1 minus starting time mi0, and our room will be free at again, room free at time. Now again our room will be free at current time, the time when the room is provided to me plus time taken by meet. Okay, so what I will push back in my queue, like room free at time. Now means next time this room will be free to me at this time, and room number of this room is room number. Okay, and at last I just written answer. Okay guys, so I hope you understand the problem. I don't know, same problem taken 574 millisecond, then 714, then 1032. I don't know why. Same code, completely same code, nothing different. I am just adding these two comment, completely same code, and one is comment. I don't know why it is like double of time. Why it is, I don't know. In context, it is 574. Now it is 1032. Maybe it's server load or something else. But so guys, I hope you all understand the problem. If you have any doubt, then just comment out. Try to dry run this, because in this kind of hitting problem, the main thing you need to do is to dry run. Okay guys, so I hope you understand the problem. If you have any doubt, then just comment out. I will try my best to explain you. Please subscribe the channel, like the video, and check out my channel for more these type of videos. I also upload gfg problem of the day solution, so please subscribe me for that as well. Thank you for watching this guys. Stay tuned.